Assalamu alaikum. The type 1 and type 2 errors in statistics has a fundamental role not only in the understanding of the results of statistical tests, but also in the understanding and interpreting of central issues like significance, probability, power, and sample size. The reason why type 1 and type 2 errors has such a fundamental role in the correct understanding of statistical tests is that in these tests we are never 100% certain that we have reached the correct interpretation of the results. There is always a built-in margin of error. Let me explain with an example. Say if there is a suggested treatment for a certain condition and we want to test whether the suggested treatment is really better than the standard treatment or not. So we run a randomized control trial. The violet group would receive the standard treatment and the green group would receive the new treatment. Now for the standard treatment, we know that the results of 95% of the patients would be between these two lines. That's two standard deviations plus or minus the mean of the violet group. Anything outside these margins would be significantly different than the results of 95% of the standard treatment. So that this line would mark the significance. Anything outside this would know that it's significantly different from the standard treatment. The green group overlaps with the violet group in a certain area here, and some of the results are less than the line, they're outside the line of significance, and some of them are more. So what happens is that we will get four different types of interpretation for any results. If the samples were taken from this area, then we can be pretty sure then they will be different from the violet area, and that's a true positive. But if they are taken from this area, still outside the line of significance, this may actually belong to the violet group itself, but they are just false positive. On the other hand, results less than this line can either be a true negative if they come from this area, or they can be false negative if they come from this small triangle there. I'll explain with some more details. The degree of overlap between the two distribution curves and the position of this line of probability, the p-value, determines the type 1 and the type 2 errors, among other things. We usually place this line at the less than 5% p less than 0.05 level in here. So anything more than that would be significantly different than the standard treatment, but that would be a positive result. Most of them would be true positive, but some of them would be false positive. On the other hand, anything less than this level would be not significantly different from the standard treatment, so there would be a negative result. Some of them would be true negative, and some of them would be false negative. The blue triangle here is the false positive, that's the type 1 error, alpha, and the pink triangle is the type 2 error, the beta. We start with the type 1 error. Take this example. If we are running a test for a tumor marker that will tell whether a patient does not have a tumor, those patients who does not have the tumor are from this violet distribution, or those who have the tumor in the green distribution. We have set the probability level at the usual position of equal or less to 0.05, less than 5%. Any data, any results higher than this line to this side of the line would be considered positive, i.e. they have a tumor, and anything on the other side of the line would be considered negative, that they don't have a tumor. Now, If you get a positive result, you can either have one of two decisions. The patient actually have a tumor, or it's a false positive. False positive belonging to this small triangle here, because the data, anything outside this limit would be positive, either true positive or false positive. So data from this small triangle would actually be a false positive, a false alarm. It would indicate that the patient has a tumor, whereas in fact he does not. He belongs to the violet distribution. There isn't much that we can do to decrease the type 1 error, the false positive, except moving this line a little bit further. If we only accept, say, a probability level of less than 1%, then it would the line would shift to this side, because you now accept only a p less than 0.01. But in doing this, you would increase the area of the type 2 error. So although you can reduce the type 1 error by shifting the line, by asking for a smaller probability for a false positive, you would actually increase the possibility of having type 2 errors. Now to the other side of the story, the type 2 error. Whereas we know that the red triangle is the type 1 error because it is lie on this side of the probability level that we have set at 0.05. The yellow triangle represents the type 2 error, which lies within the limits that we have set, but it actually belongs to the green distribution, the patients who do have a tumor. So although they do have a tumor, the results would be not significantly different from those who don't, and this would be a misdetection rather than a false alarm. By definition, a power of the study is the ability to avoid this type 2 error. So it's the remaining part of the curve. If this area of the curve, the yellow part of the curve, is beta, then the power of the study is 1. This the whole distribution of the green and distribution minus beta. The remaining part of the curve is termed the power of the study. And the more power you have, the less type 2 error you would get. So when we get a non-significant p value for a test, we're not really sure whether this would mean that there is no difference between the two groups, or that we are actually falling into a type 2 error. The answer to this would be to check the power of the study, the remaining part of the distribution here. A p-value less than this level here would either be truly negative, like most of this, or would be a false negative, like the pink triangle in here. This is the type 2 error. And we can never be 100% sure just by looking at the p-value whether this is a false negative or a type 2 error, or that's actually a true negative. We need to check the power of the study before committing to that this result is really not significant. And if the power of the study is quite high, then we know it is true negative. The chance of having the result as true negative would increase, and the chance of having a type 2 error would decrease. And that will bring us to the important concept of the power of the study. We would discuss more about this in the next presentation, but for now, the power of the study is the ability of a given study to detect a difference between the two groups. To detect a difference would reduce the type 2 error. Then you would not have a misdetection of a tumor and a false negative if the study is of high or of appropriate power. how can we increase the power of the study to make it more probable that we are going to detect a tumor marker, for example. We can do this if the difference between the two groups, the effect size is quite high. The more the difference between the two groups, the effect size, the more the power of the study. Or if we have more patients in the sample size, the more we have patients, the higher the power. Or if the standard deviation and the variance of the results is narrow, the narrower the standard deviation, the higher the effect size. Or if we accept a probability level of, say, 10% rather than 5%, but by doing this, we increase the power, but also increase the chance of falling into the type 1 error. All these will be discussed in the next presentation on the power of the study. By this, we come to the end on this short presentation on type 1 and type 2 errors and its importance in the correct interpretation of the results of the statistical tests and its importance in understanding the concepts of power, significance, and sample size.